Hashrate is sponsored by Vanta Investment DAO. Get the Vanta NFT on OpenSea and gain instant access to an exclusive community that gets allocations in cutting-edge sectors like GameFi, DeFi, artificial intelligence, and infrastructure. Vanta is a powerhouse hive mind of over 250 visionaries, from trailblazing company founders to savvy investors to a cold community influencing over 10 million followers on X. Join key industry players like Mario Nawfal, Seed Phrase, the CEO of QuantStamp, and myself, Mark Jeffrey, among others, who are already navigating the private investment landscape together through Vanta. Get your Vanta NFT and join the action today. Hello, everybody, and welcome to Hashrate. My name is Mark Jeffrey. I have two guests today from macrocosmos.ai, Stefan Cruz and Will Squires. Hello, gents. How you doing?
Hi, Mark. Nice to meet you.
Doing
nice
great.
To meet you too. I'm glad you're both in your white T-shirts, and I've worn the team white, well, sort of white shirt for today. So we're all in uniform. So I'm very happy about that.
Little serendipity. It's a sign. It's a sign that this is going to be a great chat.
Good. It's good. We've got a nice base level to build from.
We understand each other.
Yes, it's good. We're in simpatico, as it were. So Bittensor is a decentralized AI network. You can think of it as sort of this Bitcoin meets AI thing. There are 38 subnets in Bittensor, and Macrocosmos runs 4 of them. Subnets 1, 9, 13, and 25. Did I get that correct?
You're absolutely right.
All right. So before we sort of dive into that, tell me a little bit about you two. Who are you two, and where do you come from? Like, what is your background?
So I'll go first. I'm Will. I'm the CEO of Macrocosmos. My background's kind of weird, actually. I started my career in civil engineering, specifically heavy infrastructure. I worked on a load of the UK's biggest infrastructure projects and some crazy global stuff, from Crossrail to HS2 to NEOM. And I pivoted my career about 4 or 5 years into it because I looked at construction and was like, this is momentous and great, and like it's a really big thing. It's like really, really huge stuff you do in construction. But I was slightly, I guess, frustrated by how untechnologically advanced it was. So I ended up doing more of a career in AI. I took degrees in that. I ended up holding a research fellowship at UCL. But I basically spent the last 10 years building tech businesses and AI businesses in FTSE 100s, without in the startup space. And I came to Bittensor through Stefan. It's his fault we're here ultimately at the heart of it. But we've been long-term friends. We met 15 years ago jumping out of planes, and have spent a lot of our life doing slightly reckless, crazy things. So I think Macrocosmos is hopefully one of the more sedate and measured and thoughtful things we do as friends as we age and become a little bit more, I wouldn't necessarily sedate, but measured and thoughtful and slightly more successful.
Hey, Will, before we move on to Stefan, you've been working in AI for 10 years, and up until sort of ChatGPT launched, my impression of AI was it was sort of nowhere, right? Like I'm older than you guys, so from my perspective, AI has been around the next corner for about 30 or 40 years. And you know, when I was in college in the 80s, I was studying stuff that they were like, oh yeah, by the time the 90s roll around, we're gonna have the HAL 9000, and it just never got here. And then all of a sudden, ChatGPT comes out, and everything's totally different. So, what was it like working, in AI before the ChatGPT sort of moment?
So that there's a nice anecdote. I think it's called Tesla's theorem, which it says AI is everything that hasn't been done yet by a computer. So like it used to just be this like in the future there will be AI and there'll be a new threshold on a new other basis. Like at its heart, and I'll let Stefan speak to this a bit more elegantly after me. AI is just very, very complex statistics at play at different scales. And my background was doing a lot of machine learning work, specifically in sort of decision support systems. So we were designing very complex ways of reading as many signals about the performance of mega projects in construction as possible, like delivery rates, production rates, field rates, and trying to basically predict the probable futures of the project. So we were looking at how did one delay here have a cascading effect otherwise? How could we track that in real time through data and simulate projects overnight, often doing many billions of simulations. And we used AI to reduce those possible permutations to an actually computationally manageable problem. And I think, like, machine learning was kind of a cool idea that was very aware in research labs 10 years ago. You saw DeepMind beginning to emerge, and certainly in the bigger corporations, people were thinking about it, but it didn't have quite the same prominence. The big buzzword like 10 years ago in corporates was big data. Everything was about big data and the data explosion, and data is the new oil. But there's been a lot of work in data science and the methodologies that underpin that over the last 10 years coming towards it. And I mean, I was working with GPT-2, I guess, 3 or 4 years ago, when it was novel and interesting, and you were like, wow, this thing is kind of cool, but you could see it was at an early R&D stage, and it hadn't reached this sort of explosion that we see now with sort of the sort of November 2020, was it 2022 release of GPT-4 that really set the hairs running. And I think, we'll come back to this later, I guess, a bit, but when Stefan and I look at Bittensor, we very much see it being as sort of just before that R&D technical inception point of how do you take one of these technologies that's clearly promising, clearly has amazing potential, clearly can do really, really awesome things, and take it over that final hurdle into being something that is so obviously very powerful and very profound and can really make an impact. And I'll let Stefan speak in a moment, but I don't know on a lot of our basis. Maybe.
Sorry, Stefan. I just want Will to get there.
Off mark. But we see Bittensor as having a lot of potential to be equally as explosive as ChatGPT has been in a slightly different way.
Okay. Stefan, please tell us all about yourself and your background.
Look, I guess in terms of my background, I come from academia. I'm a researcher by trade. I got my PhD in subatomic physics in Vancouver, Canada, Canada's National Lab for Subatomic Physics Research, or TRIUMPH, which was a blast. I literally lived in a concrete bunker for 5 years underground. Very interesting and unique experience. And so sort of what happened...
You lived in that bunker, why? Because that's where the neutrinos or whatever couldn't get out?
Yeah, I mean, basically, yeah. This stuff has to be underground because it's just profusely creating radiation. I'm not sure if I'm allowed to use curse words on air, but yes.
Sure.
Lots of radiation, and so for that reason, all of this stuff has to be kind of huddled underground so it's getting absorbed by the earth and by concrete blocks that are surrounding you. So I'm half joking when I say we're locked down there. I was a grad student, so you kind of get stuck in this stuff anyway. But yeah, it's actually many people on the campus above ground at University of British Columbia are not even aware of the fact that there's a huge particle collider under their feet, rumbling and shooting electrons around. But
you might want to know about that.
It actually serves a very important function for the university. They produce a lot of medical isotopes, which are important for things like cancer treatments. So it actually serves a really important function. So I guess for me, towards the end of the PhD, I became perhaps a little bit jaded about the academic world and the opportunities it presented to me. I've always been quite entrepreneurial. I didn't really feel like it was scratching the itch of trying out new crazy things. Also, the sort of tools and methodologies that were used in academia at that time, and I imagine persist even to this day, they're not really cutting edge. There's a lot of physics is a very conservative community, and that's important. Physics needs to move slowly, to be honest, because physics is about really knowing what you're talking about and being able to describe it in the simplest and most powerful ways, and that's extremely important. However, for sort of the younger generations that really want to try out these tools, I mean, you talked about AI arriving almost like a train just whirring past the station. It kind of came and announced itself all of a sudden. I got caught up in that. I remember the DeepMind Atari paper dropping in 2016, 2017, where they came up with some interesting approaches to what's called deep Q learning, which is a form of machine learning, reinforcement learning. And I was spellbound. I thought, this is great. Went to my PhD advisor. I was like, I want to do this on particle physics. And he was like, no. So rebelled with me. And he was probably right. I wouldn't have graduated yet. I would still be in my PhD if I would have been trying to do that. But in all seriousness, it made me realize that where I want to spend my career and my effort is working at the cutting edge. So I love physics. There's always a place in my heart for physics, but I decided to part ways from academia. became a founding engineer at a Canadian startup that was focused on actually using physics to embellish machine learning models. So it's kind of the best of both worlds. And this was applied to manufacturing, actually. In semiconductor manufacturing, there's a lot of really complicated physics processes at play that create the wafers that we use in all of our devices. And this is literally like lasers and atomic precision placement of atoms on silicon chips, let's say. And it's literally layer by layer crystals that are completely pristine and perfect. And it's a real marvel that engineering has gotten that far. And it's actually quite surprising that there's very little machine learning in a lot of that. Even at the biggest fabrication centers in the world, they rely on traditional, tried and tested, again, quite reminiscent of the physics community. It's almost there's too much at stake for the machine learning model to go off the rails and create catastrophic damage to your factory floor. I think that's a lot of the sentiment towards it. TSMC is pumping out millions of dollars of product an hour. If you bring that assembly line down for a few hours, the cost is enormous.
Yeah, got it. So we need the humans. So we don't trust the machines totally. We still have the humans in there.
Yeah, absolutely. And to your point about like what did this look like and feel like before it kind of arrived a couple of years ago, and it was a really interesting mood towards machine learning. There were a lot of pilot projects. What we were doing is making it so that you need a lot less data to get high-quality machine learning models, and we were still kind of forced to use the simpler types of machine learning models, less the flashy deep stuff and more like the well-tested stuff. And the goal was to be able to use like 100 times less data to get really good models by teaching the model about physics in the meantime. So it doesn't need to learn from the raw data, atoms, interact with each other in some ways. There's this thermodynamical effect. We kind of baked that in. And then what followed were, again, much more sample-efficient machine learning models. So really interesting part of my career. But I guess I would just say that after 4.5 years of service there, I decided I wanted to actually do the cutting-edge stuff, because that still didn't really feel like machine learning has been moving so fast that we dug our heels in. We decided the technological solution that we were looking for at that time. We were a really small team. 4 years goes by, and the tools that you're using are just outdated completely. So that's sort of when I cut myself loose. I decided to really try and get right on the bleeding edge of the AI, what's happening in AI research right now. And I found Bittensor. I met Jake, the founder. And from there, what transpired is, I guess I've been deep in Bittensor for about 1.5 years now. Mm-hmm. And in that time, I have learned a lot about what is current in AI. I think that a lot of the things that we're solving in Bittensor as a community, not just in Macrocosmos, but they really are cutting-edge AI research problems.
Interesting.
There's this unique challenge. Sorry, do you want to go ahead there, Mark?
Yeah, no, for the people who don't know, because there are some people who watch this show who don't sort of live in our universe, right?
Right.
What, in your words, what is Bittensor and what is it trying to accomplish? And not like how it works, because we've covered that on previous shows.
Yeah.
I'm more interested in like a vision statement, like, in 5 years, if it works, what is it? Does it look like ChatGPT and it's just a lot better? Or does it look like something else? Like, what are you trying to accomplish with Bittensor?
I guess the top level value prop here, you're a crypto guy. I don't need to tell you about proof of work and its limitations, but really Bittensor is an effort to generalize the utility that can be created by the necessary proof of work mechanism. So instead of that being applied to something extremely narrow, how does one generalize that as much as possible so that all of that computational work can be oriented towards something that can be defined, articulated in a really precise way? And Bittensor is articulating this into many different directions.
Let me interrupt. So you're talking about the how. I'm talking about, right, that's how you do it, and that is a much more efficient engine, right? So I'm more interested in the why. Like, you want that more efficient engine to produce a better general AI? Is that the idea? It's smarter, it's faster, it's more honest, maybe?
It's absolutely, I think all of the above, definitely true. Additionally to that, there's also the component here where safety cannot be overstated enough, really. Like this whole ChatGPT moment that we're in, great. We have no idea what they're doing to train this thing. We don't know whose data is inside of it. We also don't really know what this thing's capable of. You can't just let this thing loose, so to speak, because it's sort of it's such an opaque system that when it's wrong, it's so incredibly profoundly wrong, it's kind of terrifying. And
You're talking about the hallucination problem?
Talking about hallucinations, exactly. Generative AI, whether it's vision, video, text, it's all the same. The problem here is that you don't really know why it came up with the next step that it came up with. And a big part of that is there's a lack of transparency around the whole life cycle of it. The data collection, the processing methods, the training methods, the way that human preferences have been used to align its opinion. Now, all of this is a reflection of its designers. And if that's all happening behind, I guess, closed doors at OpenAI, we really can't have much confidence that what this model does is going to it's going to be trustworthy and it's going to be representative of us. Do you want to jump in and add on that?
I actually look at it as, in a simple way, that AI is going to be one of the great technological changes of our time, however you look at it. And in the same way that the internet was a protocol network, but blockchains are protocol networks. And for me, Bittensor is actually the purest expression of a blockchain in that it is a distributed computer about organizing distributed resources to do computational stuff. And what Bittensor is really good at is you can write an incentive to organize computers. And what's innovative about it is the computers can organize the computers because you put intelligence in both layers. Why I think it's really important for AI in particular is... So I think it was 2 days ago, Mistral raised a $600 million Series B round a year after that.
Yeah.
It's serious money. And the reality is creating intelligence requires a hell of a lot of resources, mainly computers, to be organized around a problem. And it's not actually as simple in some ways as the original creation of the TCP/IP protocol. Like, to keep pushing the boundary of open source right now, again, just take Mistral, it's a $600 million problem. So we see a load of brilliant open source models being made available today. Llama from Meta is probably the most obvious, and the Mistral 7 billion. The reason those exist today is for strategic reasons in the marketplace. For Mistral, it was because they wanted to show they were a business that was worth $6 billion and do a $600 million raise. Mistral Large will not be open source. For Meta, it was at least in part because they were behind. And the best way to cut your competitors' ankles is to give away something so the open source community can help you chase. And we've seen that with Llama. We cannot assume that these corporate entities will continue to invest hundreds of $millions out of the good of their heart to the open source community. What Bittensor enables is a way for distributed groups of people, researchers, compute providers, data center owners, hardware owners, to organize around a common problem, which is the creation of intelligence that is more community-owned and more available. And that is really, really important. Like, AI is not two dudes in a basement. It can be. Those two dudes can be a part of something. Bittensor provides a way of those two dudes in a basement being able to compete with the big boys and girls. And I think it's really, really important because of that reason. Without that, the basement hackers who characterize entrepreneurship, characterize innovation, are at risk of being dropped out of the bottom of the economy. And
right.
I look at this small analogy. Stefan and I were speaking about starting a business in AI, a year and a half ago, and we were thinking about building something on top of ChatGPT because right then it was popular, it was cool, and we were like, well, shit, this thing is really something there. And then OpenAI released the AI store and rug pull hundreds of businesses that have built underneath them.
Yeah, I actually heard you say that, I was listening to Keith Singery's podcast where you guys appeared on that. You brought that up there too, and I didn't really understand why. Like, isn't an app store good? Like, isn't that something where the little guy can use the APIs to create something new and innovative? Why was that bad?
Well, it wasn't an app store. It was, here's our agent store, and anyone can do it, and you can't monetize your piece. You have an open source piece, and there's some idea towards it, but they basically, with the features they built, disintermediated all of these people in the long run. And again, I look at it as more analogistic to what's the content share that Instagram creators get compared to Meta's advertising revenue. Like, they get a fractional percentage of the money that comes through the machine. And that's just what the platform play from Look, it's the platform design that Silicon Valley has been pushing over the last years. Build a network effect system, ChatGPT, allow people to monetize on top of it, and then through time slowly compress their margins and pull them into your own. It's the current inevitable model of closed source, investor-driven capitalism. It's free today; it won't be free forever.
Yeah, I guess to continue a little bit along this sort of economic axis as well, there's also an efficiency problem here. So we found on one of our subnets, which is dedicated to the pre-training of large language models, which, for the benefit of the listeners, this is when they digest an appreciable fraction of the entire internet to learn a little bit about what the world is, and they can usually generate a coherent string of text as a result. On our subnet, a pool of dedicated miners, fantastically skilled, excellent people, they were able to produce a model that was higher quality than other models at the same size. So that's already par. It was sort of already at par with what's available at that sort of budget of computational operations, whatever. But they did it with 50 times less resources. So on the same data set. So this is an apples to apples, a completely meaningful comparison. The Saudis trained the same model, Falcon model, and what they found was, it took X number of A100s for X number of hours. They usually measure this in GPU hours on some particular chip. Basically, we were able to sit down with the miners and we were like, great job, guys. You're the winners right now. Congratulations. How much compute did you use? We were all completely curious. This was actually on a novelty search with Bittensor a couple of weeks ago, and I recommend that you take a look at that. It was a really interesting chat with those guys. And what we learned was basically they had found a way to innovate to make it 50 times more efficient. That doesn't happen if this is happening internally in companies. There's not the same impetus for that kind of ruthless innovation to happen. Right. This happens because the subnet is a competitive marketplace and people find ways to outdo each other using genius, to be honest.
Yeah, I see. Because if you're in a big, dumb, fat company, if you're inside of IBM, you have no impetus to, right. So I get what you're saying.
Together, the compute's this number, and then you're not going to put the energy into optimizing that because who cares? Not your money.
Well, also, just very simply, if you're under budget, how big's your budget next year? It's slashed. This is the same for university seats, right? If less people come into your university this year, you get less funding next year.
Yeah, it's bad. Innovating is bad. So, I was going to ask you, actually, where I was going to go next was one of my more recent investments is in a company called Figure AI. And Figure AI is invested in by ChatGPT or OpenAI, Amazon, Microsoft, kind of that axis, if you will, of the AI, the closed AI world, right? The very large, very perhaps malevolent, right? Depending on your point of view. But regardless, one of the things I learned in sort of that process was there's only so much GPU in the world, and and some of it and a lot of it's not available at any price, right? Because it's reserved for some of those other big centralized players. So you brought up this efficiency of 50x, which that's great because it's 1/50th of the GPU required. But in general, is the lack of availability of GPU to Bittensor compared to these centralized entities a problem? And how do you view that as a problem, or am I wrong? Is that not a problem down the road? Is there diminishing returns from it, or how do you guys think about that?
So I think point one is I don't actually believe these big companies are malevolent. I think it's worth reflecting on that. I think there's a lot of genius, brilliant people in these businesses trying to do good things. I think it's very hard to work against the economics of shareholder systems. That would be my broadest way of things. It's a really difficult space to be in. On the economics piece, what is really interesting about Bittensor is it's not our problem about whether compute is available. Right now, the compute is available, is the simplest answer. And that's what's really interesting. These guys on Subnet 9 were training on H100s. So there's this strange ability that build it and they will come is one example. If the market incentives and forces are there, the resources will make their way to the cutting edge. And there's a really nice graphic I like around this that it was in The Economist the other month, and it showed the projected growth in AI dedicated data centers by 2026, and it showed the stack of existing resources. And the current GPU, CPU allocation against crypto is higher than the projected demand for AI by 2026. So like the amount of GPUs, Bitcoin, mining Ethereum, mining other stuff is already like an order of magnitude bigger. Now those resources are allocated to doing it. Maybe they're not the cutting edge black piles and other pieces, but just at a macro scale, like the amount of resources dedicated to computational work in cryptocurrency is huge. And a big thesis of Bittensor is, as opposed to timesing SHA-256 calculations together to secure cryptographic proofs on Bitcoin, what if that work was doing intelligence work? And I think it's a really compelling use of a lot of those computational resources. I think it's why it's a really powerful project.
Yeah, no, I agree with you. I mean, my bet on TAO is actually quite a bit bigger than what I put into Figure AI. So just so you know where my heart is, right? Oh, yeah. So I'm feeling this one quite a bit. So, okay. So, but this is still a business for you guys, right? This is not a charity. You guys are big brains. You could be working somewhere else for big bucks, right? Instead you're doing this. So how is your company making money? Is it just making money on TAO emissions from Bittensor, or is there some other way in which you're making money?
So maybe it's worth like rolling out at a high level view. When Stefan and I chose to found Macrocosmos, we looked at sort of three things. One is like we wanted to be a proper AI research lab and bring the sort of skills, capabilities, and people that were needed to make AI competitive and brilliant, and the same sort of people these sort of, centralized labs are hiring into our team to work. The second point is we believe in the open source and the decentralized aspects of AI, and we wanted to organize those people around a project that would allow them to sort of do that in a competitive manner and do this sort of deep AI work in this particular space. And the third element is we're on Bittensor because it's, for us, the best place to do the first two things. Like, we're in Bittensor because we have conviction about the project and we think it's the best place to do AI in the open source in a decentralized fashion. Those things are important. Today, our business model is the current economics of TAO is we receive a slice of emissions on the subnets we build and run. And, one of our bounding principles is for Bittensor to succeed on its promise, the intelligence layer at its core has to be cutting edge. It has to be competitive with centralized programs. It has to be generally brilliant and intelligent. And that's very much the problem we sort of set ourselves out to solve in our first sort of stage of the business. Beyond that, there's a load of other things Bittensor has to solve to be successful. It has to find a way of bringing that compute into the sort of fiat Web 2 world, like in some way. Like it has to be available for enterprise businesses, for consumers, for Web 3 enterprise businesses, but also Web 2. So we're starting to think a lot more deeply about that problem and how we connect those two worlds. Like a lot of my experience was in doing big, blue chip business deals. So I've got a lot of experience in that. The thesis from our side is let's get the product brilliant, and the product being Bittensor in its whole sense. And we think there's a lot of amazing work already in the project today, but we've got some exciting things we're planning to ship in the next few months that we think are going to raise the bar. But Steph, I don't know if you want to add anything to that.
I think you go with it, fine. Yeah.
Yeah. Okay. So one of the things that when I think about Bittensor, it's sort of, I go and I look at the subnets, right? And I talk to people who are doing, stuff in the network like you guys. And I go, wow, there's a lot going on here and it's super cool. But it's not really easy for a normal person in the normal world to kind of understand, like there's nothing they can see, right? There's no front door. It's not as, there's Corcel, which is sort of a front door of sorts. And then yesterday, I think it was June, I guess it was two or 3 days ago, I randomly came across a Twitter space about something called the Request Network, a digital marketplace built for Bittensor. And the idea is that you would create some sort of a front door, and it would basically be, that's where there would be like the command line, and you'd enter in, whatever your request was, and it would then be routed to the proper subnet right, or a group of subnets, and it would be aware of all the other subnets, and the subnets would be aware of all the other subnets, and this thing would basically figure out how to get you the best answer from all of the resources available inside of Bittensor. On top of that, there would be payment rails built on top of this, so that the subnets could actually get paid via Stripe, maybe crypto native, although apparently they were saying there were some legal issues surrounding that, but clearly Stripe and PayPal and things like that. And I also, on top of that, I heard that you run Subnet 1, which my impression of that, based on reading it, is that was meant to be the front door, and I don't know if it really is, but can you guys comment on this? Do you guys think, do you feel there's a need for a front door? I do, but what do you guys think?
Yeah, totally. This stuff is, there's an unreasonable barrier to entry, both at a sort of in a technical way, if people want to participate, and also from a product and a sort of user standpoint too, right now. I like to think of all of the subnets as just some sort of service behind an API. Okay, and that's just something that you can query and you can get on-demand intelligence, whether it's file storage, whether it's inferencing LLMs, whatever that might be. What has been emerging for the last few months, we're a part of it, but we're just a small part of a bigger movement within Bittensor, is the community is organizing under the recognition that the bandwidth, so the validators play this critical role because they're sort of like the gatekeepers that allow you to enter subnets. So what is being built right now is this idea that validators should be the ones that handle these API requests from real users and route those to the respective subnets. And of course, the question that I think a lot of the community has been thinking about is, does it make economic sense for every subnet, which is already an API, to have its own front end? Maybe it makes sense when there's 36 of them or 38 of them. What about when there's 300? What about when there's 3,000? Now you've just got this entire catalog, and it's kind of, I think it's wasted work, to be honest. It makes sense to have some sort of unification mechanism that allows the user to see what is available, to send requests into the network. Ideally, those requests are handled in an autonomous way that sort of routes it to the respective subnet that can handle that request. Maybe I want someone to generate an image for me. Maybe I need to store something, so on and so forth. Now, Subnet 1's vision has always been to provide that front end. However, I guess for better or worse, our intelligence ambitions are such that we want Subnet 1 to also be a cutting-edge language model inference subnet. So for this reason, it's sort of a matter of prioritization for us right now. So we see that there's a lot of movement around this sort of request layer within Bittensor, and we celebrate that. We're really grateful that the community is moving there. What we're also seeing here is that the most natural and intuitive way to communicate to Bittensor is most likely a natural language interface. It's like a chat GPT that can reach out to all the other subnets and just understand where it needs to procure the answer from. And so that's sort of what we're building right now. And another big part of this as well is, like Will said, we're trying to build as many of the tools in-house as possible. So Subnet 1 is based on open source language models. It's currently using the latest Llama 3 70 billion model, which is considered to be state-of-the-art and highly competitive with GPT-4. That's fantastic. What if we built that model within Bittensor? So what we're looking at as a sort of an AI outfit within Bittensor is we have a subnet that pre-trains models at scale. Then we have a subnet that, well, let's say along this sort of pipeline, we have sort of the data acquisition stage of an AI lifecycle. We have the pre-training stage, when we have fine-tuning stage or stages, which kind of refine the model and make it more tailored to the use case. And then finally, we want to just actually put that model into production. Our dream right now is to really connect all of those dots so that we can say, in sort of a completely on-chain and transparent way, this model was created using this data by these individuals in this time frame, and you can basically chart out the entire ancestral lineage of a model. And then eventually, at the end of this, what we have is Subnet 1 that provides that as an LLM inference service. And I think that's a really big part of our sort of intermediate roadmap right now. Did you want to add anything?
I think the only thing I'd add is what's really interesting about Bittensor is everyone's building their own door. So there was a guy who the other day was like, we've brought Subnet 1913 online through our chatbot. And I was like, sweet, I wasn't aware you'd done this. This is awesome. Yeah. And it's kind of the thing of like, some guys like, I'm going to be a door merchant. I'm going to like put windows in. It's going to be great. And some of those doors have, more elaborate entry halls or otherwise. But Yeah, it's been really interesting that we have a view on a door. Maybe right now it's a bit more like a sort of janky porch on the sort of front of a house. I'm joking aside to that. But what we actually want to do is help, as subnet builders primarily today, we want to help people build more entry points to the network. So one of the things we're working on is shipping what I would call like MVPs or toy applications for each subnet. A chat application, like a Corsair Lite. We, like the team, like Morgan, Namare, and others at Corsair are amazing. It's an amazing product. I'm not going to be like, why would I copy Corsair and try to compete there? What we might do for similar subnets is for the subnets we run is ship simple apps that others can fork. They're open source. They can build on top of and help give people a jump start to build more doors. It's one of the things we're passionate about. We are thinking very deeply about some of the more cohesive products we want to build that I guess would celebrate and potentially create a monetization route for some of the things Stefan mentioned about this sort of AI loop. But it's a community project, and we want to fly the open source flag a little bit. So actually, if we can ship, the same way all of our subnet code is open source, and we're trying to push the innovation and incentive mechanisms in the design of subnets, and this is still a new technology. The first subnet was subnet 3, like 18 months ago. The explosion at Revolution was 9 months ago now, and like when you think that this is 9 months from like starting gun on 15 startups, Macrocosmos has been live for about 10 weeks now. We've been actually active as a business. We've ramped from the sort of 4 founding engineers who joined from OpenTensor to, I think we're 21 today. So,
wow.
Yeah, so we've not really been sleeping as we've sort of been building out the team and building velocity. And, you're going to see us moving faster and faster and more aggressively over the coming weeks as we sort of ramp people up to speed and teach them this crazy language of Bittensor. But I think people can forget how new this is sometimes. Yeah. And one of the things we really want to do is bring a professional edge to Bittensor and how these subnets get built and make them really, really good. And we're very fortunate. Some brilliant people have chosen to join us. Stefan jokes, I think we have more PhDs than the rest of Bittensor combined. I think we're at
Yeah, and I think that's a good anchor point here. Imagine a pre-seed or stealth mode startup, if we were to sort of map an analogy here, in the Web 2 space, even if it was AI, how long would the market expect it to take a small team of those people to produce a product and go to market with it? I think that in many ways, Bittensor is still finding product market fit in meaningful ways. And to me, I am not a UI UX guy. I'm a researcher. What fascinates me about Bittensor is the research opportunity to be able to have this highly directable machine learning articulation that happens entirely within the machine of Bittensor. To me, that's what kind of keeps me excited. Will is the product mastermind, so he should only be allowed to talk when you ask product questions, to be honest. But I think it's important.
He just likes dashboards. All he wants is dashboards.
Yeah, no, but I think it's important to have productization because you don't get evolution otherwise. One of the things I've actually been sort of frustrated with, in talking to the Bittensor folks, I love the vision. I've invested in the vision, but I don't know how many people are using it. I don't know, are a lot of these subnets just sort of sitting around and people are going, oh, wow, this is super cool, but nobody's really using it. And I don't really get a sense of the usage. And I don't really get a sense that usage is valued and rewarded, right? Because you make the same amount of TAO no matter whether you think it's used or not, right? It's just about, is it good, right?
Yeah.
So
right.
You're a science project, right? Congratulations. So do you guys feel me on that one? Do you agree?
Yeah, I think that historically and up until now, the root network, which is sort of the de facto governance mechanism and is the vehicle that allocates emissions to subnets, we all know that it's not really the right way to allocate rewards. It doesn't really reflect value creation. They're not as tightly coupled as they should be. Let me put it that way. And I think that what's coming down the pipeline with things like STAO and DTAO is what you're talking about here, which is subnets that are actually interfacing with the real world and creating real value. That needs to drive their revenues. That needs to increase their emissions.
Yeah.
And I think that those two markets are going to become more coupled with sort of the forthcoming DTAO release. A huge part of it as well, it's just impossible to overstate how complex it is to maintain these subnets. They need to be stabilized. They need to be fully, you've got hundreds of people throwing so much compute and effort at these things, they do need to become stable and sustained in order to be able to build anything meaningful on top of them. Otherwise, you're building a quicksand. So I think there's this sort of, the cycles within Bittensor happen sometimes on the course of hours and days. You see sort of subnets rise and fall, not that they're getting registered and deregistered necessarily, but sort of exploits come, which exploit is that's the word that all subnet owners wake up in cold sweats about in the night. Someone's exploiting. And what this really means is they've found a way to short circuit the intended use case. And they're basically, the miners are able to inject the reward right into their heads without actually doing any of the work. I think there's so much interesting work that needs to happen there as a complement to the apps and the value creating aspect of Bittensor, and one can't happen without the other.
Okay. All right. I want to move us along now because we're sort of sweeping up on the hour faster than it's going by so quickly. And I want to get to some of the subnets because some of this is very specific and very cool. And I want to start with subnet 25, the protein folding subnet. So tell us what that is and how it works.
So this is something that we've had on the back burner for longer than I'd like to admit, probably 6 months. We've been thinking about this. Bittensor has traditionally been oriented towards AI use cases, and we love that. But we thought, especially for me coming from a research background, there's this whole food chain within academia and research about people that get access to HPCs, to clusters, to do their research. A lot of simulations are very computationally intensive, biological simulations, physics simulations, engineering simulations, all of the above. And we thought, well, I mean, if you sort of zoom out of Bittensor from the AI perspective, it's just a decentralized supercomputer that can, access this massive reservoir of computational possibility, let's say. So we've been thinking carefully about how do we do something like folding at home, which is, of course, it's an analogous system, except it's not voluntary. This is something that directly compensates, or should I say subsidizes people operating within the network. And the goal of this subnet is, in the short term, to give researchers an opportunity to just sort of drive this thing. And it's
what is protein folding? Let's go back. I want to make sure people can follow that for a little bit. I have sort of an idea, but give me the explanation.
Look, absolutely. There's a very well-known phrase in molecular biology, which is form defines function. So a protein is just a long chain of amino acids. They serve an essential biological function in the body and in nature. They're everywhere. Most things are built proteins. What's important about protein folding is proteins have very specific shapes, and the shape of those proteins defines how they interact with things around them, whether they are toxic, whether they are nourishing and supporting to growth. So the shape of a protein is, in some sense, the only thing that matters in most biological settings. And in fact, the shape of a protein depends on the exact environment that you put it in. If you put it in a highly acidic solution versus a different biological scenario, it will converge to a different shape. So this is a very delicate and an extremely complex process that nature just does effortlessly and automatically. But researchers are always interested in being able to study in a software simulated environment what are the expected properties of proteins. So what therapies can I build? What pharmacological products can I build from those proteins?
So the problem, let me just state the problem here. So the problem is that normally you need to test these protein shapes experimentally in the real world. And there's probably some insane number of combinatorics. So it's very, so basically you want to run all the different possibilities, which is just a crazy amount of work in the physical meat space world. Wouldn't it be great if this was all digitalized and you could run it a lot faster? You could do a lot more of them. That's pretty much what we're talking about here, right?
That's a big part of it, yeah.
Yeah, and I think, it's protein folding has been a really big use case for AI in general. I mean, Google have focused on it, DeepMind have focused on it, AlphaFold and otherwise. So we saw this sort of coming together of a really good AI and computational work use case, protein folding, with the sort of original way it was solved, which is how do you steal a bit of your computer at home? And we wanted to crash the two ideas together. And what's really interesting about protein folding is it forces a lot of innovations in incentive mechanisms that we think could go back into Bittensor and support other projects. So one of the things we think is really important for the evolution of Bittensor is something we call directability. So how do validators and users allow you to sort of fine-tune and direct a subnet through time from the sort of higher echelons of a product? And it's one of the things you really need to build products on top. One of the innovations in protein folding is we have a job store where we have hundreds of miners solving thousands of proteins at any one time. So you need to track them. The reward signal needs to be about how are you solving 100 proteins that some of them take 10 minutes, some of them take 2 days. So all of these little things of different lengths of jobs, different coordinations, how does one group oversee a bigger group that's doing lots and lots of different problems for different people is a massive Bittensor problem. And we launched the subnet about 3 or 4 weeks ago. We had a load of challenges, things we didn't expect and otherwise, but it's starting to stabilize now. And we actually see a lot of addressability in the work we've done on 25 going back into the other subnets we run, but also being available for others to build on and fork on top of. And I think the reality is these things self-reinforce. I think one of the comments you were asking earlier was about, how do we choose which subnets work? How do we choose which subnets are at product-ready state? And the reality is in any startup or any growing tech company, you have things at different stages of research and development. We felt a lot of the work on protein folding was stuff that doing it would help strengthen Bittensor in the long run. We have some things that we think are nearer to market. You have things like Corcel that are obviously there. And I think over the coming months, it's important to have that balance of how do we do the deep work we know needs to be done to get this thing to the next level versus how do we make sure we get product market fit and start showing the power of this thing in the immediate term.
Yeah.
Well, this certainly seems like something pharma companies would love, right? So this subnet feels like it could print money. You find the right protein that does, you find Ozempic or whatever, and all of a sudden you're rolling in some dough, right? So who is using this, right? Is it being used by anyone right now, or is it still sort of under construction?
I would say we've already launched, but we're stabilizing it right now. So in the short-term roadmap, we've got some collaborators in the UK that are going to start directing the subnet. You can think of it as like it's defined functionally as the user can just specify the specific protein and some environmental configuration parameters, and then sort of the machine just whirs, and then it sort of spits something out when it's done. So for that reason, hundreds of researchers can simultaneously be specifying their particular research paths, which is what's one of the nice things about the design, as Will was alluding to. It's something that will lend itself very naturally to like an on-demand folding service, basically.
Wow.
Yeah.
Okay.
And something else to add on this, something that was impressive for us to see is these miners are so motivated and they're so resourceful that they've already optimized the way that this open source simulation software is called GrowMax. It's like industry standard, state-of-the-art protein folding software. They've already found ways to unlock this software on GPU hardware. Originally, we shipped the code with, we call it a base miner, which is like a simple implementation. It's plug and play. And it's a CPU bound. It's basically multiprocessing. What they found is ways to do this on A100 chips. So now the best miners did this for a few days, and then all the other miners were no longer competitive. So what did they do? Now they're all running A100s. So you get this wonderful effect where it's always a race to the bottom. Because of the competitive possibility, as soon as someone out-innovates everyone else is like, all right, what do they do? What do they do? And they sort of self-organize again. And now it's just constantly leveling up, and we can't even mine on our subnet. We literally wrote the rules. We cannot compete with everyone else. So to me, that is what success looks like.
That's super interesting. So basically, you've got these. So I guess I'm wrong when I say there's no evolutionary pressure currently in Bittensor. There is evolutionary pressure. It's just not where you normally think of it. It's the pressure is to innovate to compete for TAO rewards by solving the stated problem of the subnet better than everybody else who's competing for those TAO rewards. And that particular evolutionary pressure is insanely intense. And I guess I've been underestimating that. Fair?
Fair.
Yeah. Okay.
Like in the sort of primordial soup of Bittensor, it's like dog eat dog, cutthroat. Like, the miners are crazy. And I think one of the things that is different about Bittensor and people haven't realized is like, so I worked in FTSE 100s that really struggled to acquire AI talent, is the simplest way of saying it. Like, They had loads of great ideas and things they wanted to solve in doing that, but finding people who could like do that work, build a model, train a model, access those resources is like a non-trivial problem if you're like a business where technology isn't your business at heart. You know, and a lot of these firms are transforming and doing it, but the race for talent is really strong. What we see a lot of the things with like pre-training, for example, is say you're a business that I've used this example, you're a firm building electric scooters, you want to train an on-camera computer vision chip that runs on your scooter and activates the brakes when it sees a child running in the road or whatever it might be. You've got to hire and build a whole AI team of specialists to do that, to train that one thing or work with a consulting group. If we can find a way to make these pre-training subnets directable that say you can specify the type of model, the training data, what you're looking for and the outcomes, that to me is an amazingly interesting part for monetization of Bittensor, because you're monetizing the resources, the innovation, you're drawing people to the ecosystem, and you're helping companies that can clearly see the opportunity of AI but may not want to like build it themselves and hire a load of software developers to access that. So one of the things I spend a lot of time thinking about and been talking to everybody from the foundation, the validators about, is how do we go and do some proper market testing of that process? How do we actually go out and talk to 50 blue chips and say, would you buy this? How would you buy it? What would be the constraints around purchasing this? Because there's some simple calls to arms in the community of like, oh, I'll give the first person who makes $20,000, you know, my weight or this or that. And that's all fine. But like building a sales funnel, a go-to-market strategy and all of that for either a subnet or Bittensor is a non-trivial problem. And like sales requires a lot of resources, a lot of thought, and a lot of effort. So we're starting to think a bit more about that. I think other teams in Bittensor are as well. But I think the opportunities and like abilities of these systems becoming more clear can only be helpful.
Yep. Okay. So what is sort of the vibe with everyone? You know, there's X number of people working on Bittensor in some way, right? Whether they're defining subnets or they're miners or they're validators. First of all, how many people sort of in aggregate would you say are working on this? And second of all, what is the vibe in that community? Is it like the Hunger Games where they're all competing with each other? Or is it more sort of, you know, Starfleet Academy where, you know, there's a idealistic future and not much conflict. Everybody's sort of helping everybody else. What can you tell us about that?
Yeah, look, by my estimation, I think the Discord for Bittensor is a pretty good litmus test in terms of the engaged, highly energized community around Bittensor that are probably participating. I put that number at 4,000 or 5,000 people. 4,000 or 5,000 people are the builders of the entirety of Bittensor up until now. And it's probably, there's like a kernel of 100 people that are doing most of it, all of it. So that's my first point here, right? That this is so nascent. Primordial soup is a good way to put it. It's what happens when that 10x's, and what happens when that 10x's and introduces a lot more, you know, high caliber researchers, product geniuses. This is a tiny boot camp right now. So that's probably a sense of the current size of it. In terms of the mood, I think it's we are, I think, affectionately known within Bittensor as good guy Macrocosmos. We tried to play a fair game, kind of like the gentleman of it. Look, every subnet has its own culture in a way. Some subnet owners treat the miners with a mixture of sort of standoffishness and sometimes even contempt. Because they just see them as the people that are breaking their beautiful code base, which is not unfair to say. What we tend to do is we give quite a lot of support to everyone that works on our subnet. So whether that's like we give them, to the best of our ability and our capacity, we give them a competitive starting point they can use as a springboard to mine. People are eternally grateful for that opportunity. We're generally very communicative. We're very organized around how we run things. We take feedback quite gracefully. For that reason, the sort of the climate within our subnets is usually people are really happy to be on board, are quite complimentary. There's an irreducible amount of chaos in any subnet, but I think that we're quite good at sort of stemming that. Other subnets, it's kind of, it's like fire. Whether it's the miners that are infuriated because like they're undercutting each other, or the subnet owners like, I'm turning this thing off and you guys get out of here. That's the beauty of it being decentralized, right? It's not just a reflection of what I think Bittensor should build. It's every group is kind of they're creating their own sort of microcultures.
And I think the only thing I'd add to it, I think, is like at our heart, we're TAO holders. We're TAO holders both philosophically and we hold TAO. Our business is built on it, and that means there's a real great ethos of like we try to do things that are good for Bittensor. Open sourcing applications, helping communities. We got a call with a guy who's trying to enter the ecosystem just after this to give him a bit of advice. We're adding a bit of muscle to our HR function and saying, actually, can we help the foundation or things like that? Like, it is this big, weird, wetware company is how Jake describes it, with the added element that if we lose and another element in Bittensor crushes us and grinds us into a pulp, that's kind of great because it means they were better than us. And we're still TAO holders. So that doesn't happen in business. Usually when you lose in the marketplace, you're out, you're dead, you're down there. But for us, if we get sort of completely beaten to pieces by Datura or Corcel or otherwise because they're so much better than us,
good job, boys.
Thanks.
Yeah, you still own TAO just like they do. Yeah, that's a very interesting dynamic. I'm trying to think of something that's similar to that, and I can't really offhand. So that is sort of a very new dynamic.
But the way we look at it is we want to raise the bar, and that's what we're here to do. We want to professionalize subnet teams. Like the original Genesis of 32 subnets had like some developed like a half-time developer here, somebody doing it on the side of his day job there. Like we see teams of like much more like 8 or 9 on subnets in the future. We're finding having a bigger team is giving us a lot of self-reinforcing elements between the subnets. We're starting to even do things like decompose the work into common repos, sets of utilities, pieces like that, which will make us go faster, but also make the community go faster. So there is this network effect you get that we're hopeful we can improve the functionality and the capability of our own subnets, but also help the community grow.
And I guess just to close that notion a little bit more, what I really aspire to build here is, I think that the language of incentive mechanisms is very young. It's very hard to frame it. It's sort of this love child of a loss function from traditional machine learning with this economic component. The articulation of it's still very rough. And I think that where we will go as a community is we will build more and more abstractions. There's sort of common components to an incentive mechanism. I want to do roughly this thing. So there should be like a high-level function or object that can kind of encapsulate that intention. Where we're at right now is we're effectively writing assembly. We're writing zeros and ones and very crudely saying, like, I want people to do this. I think where we'll eventually get, and it might be a 6-month thing and it might be a couple of years before we've really sort of polished this, it's sort of, you have very high-level abstract concepts that capture all of that below it. And usually it is by building abstractions that you can, release your mind to think about the sort of the broader and the bigger pieces without getting sort of bogged down in detail. So that's what I hope that happens in the incentive landscape.
Yeah, super interesting. And I think, it reminds me of this whole age of AI right now and sort of seeing what Bittensor is doing versus OpenAI versus, all the closed people and the very large, very centralized people. It reminds me very much of the operating system wars, kind of in the 80s, when we had Unix was like the old thing that was like from the 60s, and it was still hanging around, but it was going to go away soon. And you had these new operating systems like Windows, right? And OS2 from I remember that from IBM, and basically it was very obvious that one of these big company produced operating systems was going to be the standard and was going to, Unix was just going to go away. That was going to be the MySpace, don't worry about that. And very surprisingly, despite all the efforts of all the big companies and sort of unlimited money, Linux, that the answer was Linux. And that was a very weird, like nobody saw that coming. Nobody thought that was going to happen. Like literally nobody had that on their bingo card. That's the crazy thing, right? Mm-hmm. And this feels to me like the Linux of AI, right? Like that is sort of what
we're building. Type of it. We're building Microsoft.
Well, often jokes about this, but actually, the genesis of the name Macrocosmos was an operating system for the macrocosm of intelligence. So that was actually baked
Macrocosm
into
OS, yes,
our
exactly.
original, one of the plays on words we had within that we very much see our role is to build that operating system for intelligence within Bittensor. And I think you're absolutely right. It's the best analogy I have for it, Mark, that like we are trying to work out how to do this. And, you know, we run Linux on our machines. So you can sort of see where we sit from that side.
Yeah, we know how that all went. Well, look, we're coming up on the hour mark here. So closing thoughts, and where can we find you both online, and whatever you want to plug? Go for it.
Yeah, so on Twitter, we're MacrocosmosAI. I'm W Squires. Our web handle is macrocosmos.ai on the website. But we're on Discord as Fox and Crux. And I think, you know, thanks so much for having us, Mark. This has been a real blast. We'll retweet and tag all of these things afterwards, so I'm sure you'll be able to track us down. But look, perhaps the only other thing is we run a Substack where we talk a little bit about what we do in more detail, more effusive. So if you want to hear more about anything from protein folding to pre-training to OSs and macros, that's where to find the real deep stuff.
Yeah, and we're hiring. So anyone out there that wants to get involved and start building Bittensor with us, reach out to careers@macrocosmos.ai.
Especially if you have a PhD.
Oh, especially if you have a PhD.
Definitely not snobs.
All right, everybody. This has been Hash Rate. My name is Mark Jeffrey. We'll see you all next time.
Cheers, Mark.